right, here's another example. Now in this case, we have a two-dimensional area and we're given a density function that's based on the area, and the density is varying in the x direction. So that probably means we want to integrate in the x direction. And we're asked to find the total mass of this triangular region and with this density function. All right, so we need to like break this thing down into little bits of area, right? So we're going to slice this thing up. So if I take a little slice like this, then the thickness here is, the width here is delta x, and the height is essentially y. So if we find an equation for this line, that'll tell us what the height of any one of those little slices is at any given point x, right? So now I can see there's a y-intercept of 1, and it looks like we have a rise over run of, so we're going up 1 and over 2, so there's a slope of 1/2. So the equation of this line here on the left-hand side of the y-axis is y equals 1/2 x plus 1. Now, that function will be fine from -2 to 0. But when we come over here to the right side of this triangle and we look at slices over here, we have a different function that defines the top boundary of this area, right? So if this is delta x and this is y, y is something different over here, right? Because now this line is going down, so a rise of -1 and a run of 2. So we have y is equal to -1/2 x plus 1, because the y-intercept is 1. Okay, so we're gonna have to evaluate the mass of this triangle in parts. Okay, we're gonna have to do the left half and the right half. So the first thing I'm going to do is I'm just going to look at the left half of this triangle. So for x between -2 and 0, okay, the mass, let me just write that down, mass is equal to the integral from -2 to 0 of the density times the area of each slice, right? So the density is 3 plus x, and then the area of any given slice is 1/2 x plus 1 dx, right? So the dx represents the width. So this whole thing essentially represents the area of one slice. Area of a slice. Okay, and of course then this is our density. Density. So we're just taking density times area, and then we have to add up all of these little slices using an integral. All right, so from here it's just basically, it's pretty straightforward. pretty straightforward, right? So first thing I'm going to do is just expand this this product here. So I have two functions. So what I end up with, let's see, I can take x times 1/2 x gives me 1/2 x squared. And then if I take x times 1, I get x. And if I take 3 times 1/2 x, I get 3/2. So I end up with 3/2 x. So 3/2 x plus 1x gives me a 5/2 x. And then 3 times 1 gives me a 3. So essentially what I did is FOIL it. You might have learned it in algebra as FOILing it, right? So, but then it's just much easier to integrate, right? So what I end up with is, so the integral of 1/2 x squared becomes 1/6 x cubed. And the integral of 5/2 x becomes 5/4 x squared. And the integral of 3 is 3x. And then I want to evaluate that from -2 to 0. All right, so let's put in our numbers here. So when I evaluated at 0, everything is 0. So really all I have to do is evaluate it at -2. But remember, I'm taking the function, the antiderivative evaluated at 0 minus the value evaluated at -2. So it's going to be a negative everything, and then I'll put in -2. So it's being 1/6 and -2 cubed plus 5/4 times -2 squared plus 3 times -2. Okay, I like to write it all out, otherwise I make sign errors. So let's figure out what that is now. So -2 cubes becomes -8, and then it's the negative of that, so it becomes 8/6, which is actually 4/3. I'll just leave it as 8/6 for now. And then I'm going to have, so -2 squared is a +4, so this becomes a 5. So this, and then, so it becomes minus 5. And then I have -6, but then it's a minus -6, so it becomes +6. All right, so when I add that all up, I'll get 7/3. All right, well, that's half the triangle. So we just need to do the same thing on the other side. So let's do that. Let me scroll down a little bit. And so now I'm going to look at the triangle on the other side, the other half. So I want to evaluate from 0 to 2. Okay, so we want to find the mass of that. But it's basically going to be similar, except that I'm integrating from 0 to 2. Density function is still 3 plus x. But now I have the boundary that's defined by -1/2 x plus 1, and then dx. So so now I'm gonna expand. I'm gonna multiply these two binomials, and so integral from 0 to 2, I get -1/2 x minus 1/2 x squared, right? So that's the x times the -1/2 x, and then I get -1/2 x plus 3 dx. All right, so now let's find the antiderivative of all of that. So I'm going to get, let's see, I'm going to get -1/6 x cubed minus 1/4 x squared plus 3x evaluated from 0 to 2. And then I can plug in the 2, and that gives me -8/6 minus 1 plus 6. And I add that all together and I'll get 11/3. All right, so now I've got both the left and the right hand side of this triangular region, and so I just need to add it together. So the total mass is equal to 7/3 plus 11/3, which is 18/3, which is 6. And my units are in grams, right? Because my density was in grams per centimeter and all of my dimensions were in centimeters. So I have a total mass of 6 grams.